Okay, so this lesson is on combining like terms. And when we talk about like terms, we're talking about there's two groups, basically. We can organize each term into variables, variable terms, in other words, terms with a variable, or constant terms, that means terms without a variable. And the sign in front, whether it's adding or subtracting, tells essentially if the term is positive or negative. So if I was to highlight all the variable terms orange, I'd have a positive 7x because there's no sign in front, a negative 5x because there's a minus sign in front of the 5x, and a positive 4x because there's a plus 4x. And so our terms would be 7x, negative 5x, and 4x. So I could also list the constant terms, in other words, the terms without a variable, as positive 3 because of the plus in front, positive 8 because of the plus in front, and negative 1 because of the minus in front. So then the constant terms I highlighted pink. So we've got positive 3, positive 8, and negative 1. And notice the positives, I didn't list the plus at this point. Now, coefficients. Under the variable terms, we consider the number in front of the variable the coefficient. So that's a vocab word. So basically in 7x, the coefficient is 7. In negative 5x, the coefficient is negative 5. And in the variable term, the coefficient is 4. So basically, it kind of boils down to all the orange terms, kind of, because they're all variable terms and they have the exact same variable with no different exponents, like we'll get into exponents next semester, we can add or combine all these like terms, because they have the same exact variable, by basically adding the coefficients. So if I do 7 plus negative 5, that's positive 2, plus 4, that's 6. So all of these terms add to a 6x. And then if I combine or add all the constant terms, so basically 3 plus 8 plus negative 1, or 3 plus 8 is 11 plus negative 1 is 10, but since it's a positive 10, I'm going to write it as plus 10. Another way you can think of it, I tend to tell students they can also box all the variable terms, and you can underline or squiggly line, it doesn't matter, all the constant terms. And so again, we just, for the variable terms, add the coefficient, 7 plus negative 5 plus 4, but then you keep the same exact variable. The exponent doesn't change because we're not multiplying. It's basically like how many oranges and do you have total. So if I have 7 oranges, or I owe somebody 5 oranges, and then I add another 4 oranges, I have a total of 6 oranges. Just one way you can look at it. Now, I want to point out, so like number 1, they're both x terms. So they're both variable terms, and it has to be the same exact variable. So all we do is add the coefficient, so then that's 9x. Same thing, 9a minus 10a, they're both a's, so that's actually a negative 1a. We can actually write that as negative a. So a negative in front of the variable, if there's no number written, there's a 1 there, we just don't always write it. It's more correct, or the higher level of mathematics will write it with a negative a without the 1. You can write the negative 1 in front of the a, but it's just higher level thinking to not have the 1. And later on, when we do more of the order of operations and evaluating expressions, if there's a negative in front of the variable, we'll always read it as a negative 1 times the variable. Okay? So here, I would actually combine the 7m and the negative 5m, but there's only one constant term, so there's nothing to combine it. So basically, between the m's, I would basically think 7 plus negative 5, which is 2m, and then I would copy the minus 6 for the constant term because there's nothing to combine it with, and there is your correct answer. Like in number 4, now this is a good example to remind us actually variable terms have priority, so they get to go first. So if you notice, there's only one variable term in number 4, so the negative 6x has to come first. And so I would add 9 and 5. And just like there's no sign in front of the 9, we know it's positive, because if it was negative, we'd have a negative sign in front. But if we combine 9 plus 5, we know that's 14. And since it's positive, we put plus 14 to indicate that it's a positive term. But we can't combine them. It's kind of like oil and water, variable terms and constant terms, you can't combine any further. So I would start here with the variable terms, and I have 7p and negative 9p, so if I add the coefficients, 7 plus negative 9, there's more negatives, so it's negative 2p. Then if I combine the negative 1 and the positive 5 as my constants, well, there's more positives, and we subtract, so it's positive 4. Number 6, again, start with the variable term, so we have a positive 5h and a positive 7h, because we always take the sign in front, and if there's no sign in front, we assume it's positive. So 5h and 7h, they're both positive, so that's 12h. And then the negative 6 and the negative 8, they're both negative, so we just add them and they're going to be more negative, so it's negative 14. So the constant terms always come last. The variable terms always have priority, so they get listed first. We'll actually talk more about that when we get into polynomials. It's called descending order. So the variables with the highest power come first, and then your constant terms go last. Now notice in number 7, it's 5x squared and a 7x squared. Because they're both squared terms, we can combine them. And basically, again, they're both positive. We just add the coefficients, so 5 plus 7 is 12, and the x squared doesn't change. The only time exponents change is if you are multiplying. Here we're adding. Exponents do not change when you're adding. Now in number 8, you notice there's many variable terms. So we only combine the terms that have the same exact variable. And we do this alphabetically. So we're going to start with the x's. So we have the 5x, negative x, and 3x. And remember, this negative x is the same thing as negative 1x. So if you need to write a 1 in there to remind you that it's negative 1, go ahead. Otherwise, I see a lot of mistakes where people forget or overlook that term. So I just think, well, 5 plus negative 1 is 4, plus 3 is 7. So we have 7x. And then I'm just going to underline the y's. They're both positive, so I'm going to add their coefficients. 7y plus 2y, I just think 7 plus 2 is 9y, and that's your final answer. And we can't do anything because you can't combine variables unless they're exactly the same variable. Okay, so number 9, again, I'm going to start alphabetically and combine the 26x and the negative 4x, which they're opposite signs, so you subtract, so that's 22x. You keep the variable the same, and then I'm going to combine the y's. So 2y plus 10y, they're both positive, so we add them, and you get 12y. And number 10, notice all of them are x cubed. So we're going to add all the terms. I'm not even going to box them because they're all the same, so I'm just going to think, well, I just add the coefficients. Well, what's 8 minus 7? That's 1 plus 16, so we have 17x cubed for our final answer. And the variables, once we know that they're like terms, they're exact same variables, the exponent doesn't change. Now number 11 is if they have multiple variables in each term, as long as the exponents match, so like in this first term, a squared, and then there's only one b, so there's two a's and one b. Same thing here, there's two a's and one b because of the exponent. The coefficients are different, so we just combine these two terms and we use the coefficients and add negative 4 plus 10, and again, because they're opposite signs, we subtract, so we get 6a squared b. And since the variables never change, we keep the same exponents as well. And then the plus 7, there's nothing to combine it with, and it's a constant, so it just goes at the end. So like in number 12, if you look, we have an x squared, but there's no other x squareds. We have a 2xy and a minus 7xy. Well, I can already tell that these are like terms. And then there's a 4y squared, but there's no other y squareds. Now, remember I talked about that descending order? We actually take the highest exponent on the variable that comes first alphabetically, which is x squared. And that's the same thing as 1x squared, but there's nothing to combine it, so I just write the x squared first. Then I actually use these two terms to combine them because we have to use up all the x's first. Think of alphabetically using up all the x's. And so we have a positive 2xy and a negative 7xy. We just add their coefficients since the variables already are the same. So we think, well, what's 2 plus negative 7? Well, there's more negatives, we subtract, so there's a negative 5xy. And the variables don't change, just the coefficients. And since there's no other y squared, we just copy the plus 4y squared at the end. And again, oops, I forgot the exponent. The reason why the y squared goes last, because we had to use up all the x's first, because alphabetically all the x's come before the y's. We'll get more practice with that in the next, or when we do polynomials. So, same idea for number 13. There's only one term that has an a squared. So that term's all by itself, but you see this 7ab and the negative 10ab, we can combine those, but there's no other b squared. So the a squared and the b squared, there's nothing to combine, so we're just going to copy those. But alphabetically, we want to use up all the a's first, and we start with the highest power. So we just copy the a squared, because there's nothing to combine it with. Then, since we have the 7ab and the negative 10ab, we're going to add the coefficients. So 7 plus negative 10 is negative 3ab. Remember, the variables don't change, only the coefficients. And we copy the plus b squared. Since we used up all the a's, the b squared goes last. Now, number 14, that shows you they're all x's. However, the x squared terms are different from the x, which actually means x to the first, because there's only one x term here, but these have two x's in each of the terms. So the 4x squared and the negative 3x squared we can combine, and the 2x and the 8x we can combine. Now, for the x squareds, we're going to start with the highest power. So not only do we do alphabetically, put the variables in order alphabetically, but we also go in descending order by exponents. So the highest exponents has the highest priority, and the lowest exponents go later. And if we add the 4x squared and the negative 3x squared, basically we just add the coefficients. So 4 and negative 3 is positive 1, so a 1x squared. And then if we add the 2x and the positive 8x, we just add the 2 plus 8 is 10x. And actually, because of this 1x squared, we don't even have to write that. So the more correct answer is just x squared plus 10x, because the higher level thinking sees this x squared and knows there's a 1 there, but it's just not written. It's okay to do this, especially in the beginning, but later on in the year, you'll get better at reading this and being able to see the 1 without writing it. Now, the reason why we have perimeter problems is perimeter, you're adding the outsides. So if we're going to add the whole outside, basically we need to combine like terms. So we need to add the 2x, the 3x, and the x, because those are our variable terms. And then the plus 1 is the only constant term on all three sides of that triangle. And remember here, this plain x, we have to read it as a 1x. So if I add the coefficient of all the x terms, 2 plus 1 is 3, plus 3 is 6x, and then we do the plus 1 because there's only one constant terms. Okay, the plus 1 you can't combine with anything else. And again, when you add variable terms, the exponent on the variable never ever. I know that I have two sides of the y plus 2 that are the same, so I could do 2 times y plus 2. And I have two sides that are the y minus 5, so I could add that to 2 times the 3y minus 5. And the reason why I'm showing you this is because we can distribute this, which basically means we're sharing the multiplication through all the terms and then collect like terms. So you could write it as 2y plus 4 plus 6y minus 10, and then I could just combine the 2y, the 6y, and then I would combine the constants 4 and negative 10. So this would give me the 8y, and then 4 plus negative 10, there's more negatives, so we subtract, that's negative 6.